All right, this is Unit 5. Unit 5 review has to do with the derivative graph. And can you interpret a derivative graph? And number one, it says, looking at the derivative graph, can you find where the absolute minimum occurs? And so when you think of the absolute minimum in terms of it, the start of this derivative, all of this area, it means the value of the function is increasing. So as this derivative is a positive derivative, it's telling you that it's increasing. It's increasing, it stops, it increases some more, and then this part, it's decreasing. So that's increasing, and that's decreasing. Where is the absolute minimum if you can understand conceptually what's happening? And it's right there at the beginning. Whatever the value is at the beginning, it increases from there, and then there's a little decrease at the end after you've done all that increasing. So at what x value would you have the absolute minimum? And it's at the beginning. So the answer to 1 is A, it's 0. Question number 2, you're given a derivative graph. And it says, what is the value at which the absolute minimum occurs? So whatever value we started with, it increased. Now, the size of increase is the area. And then after it increased, it decreased. And look at all of this area that decreased. So conceptually, can you see how much larger this area is than it was above? So where did the absolute minimum occur is right at the very end. So whatever the value was, it had a little increase, and then it just kept decreasing, keep decreasing, all the way to 2. And so at the very end is when you would see the absolute minimum. So the answer is E. Number 3, the absolute maximum of that function, like this. Can get it focused in a little bit. So the absolute value of that function, x cubed subtract 3x squared plus 12 on this closed interval, occurs when x equals what value? So to understand this, if I want to find the absolute maximum, I'm going to start with the table of values. And we're going to start with the ends of the interval. So -2 and +4. Those are the ends. I'm also going to take the derivative and make it equal to 0. So if I take the derivative and make it equal to 0 and solve it, I can factor out a 3x, and then I can solve it from there. So x is 0 and 2. That has to be in my restriction, which it is. So the restriction goes from -2 to 4. So 0 and 2 are in that restriction. If not, I'd cross it out. And now I have 4 numbers to test. So for each of these numbers, let me minimize that part. All right, for each of these numbers, you just plug them into f and then get an answer. So -2 cubed subtract 3 times -2 squared plus 12. Just plug -2 in. That gives you the answer -8. If you plugged in 4 into f, that gives you the answer 28. 0 gives you the answer 12, and 2 gives you the answer 8. Out of those, at what x value does the absolute maximum occur? And you can see it's right there. When x is 4, it gives you the greatest value. So the answer is A. Number 4, the function f is defined on the closed interval. F at 0 equals f at half equals, and f at 1 equals on the open interval 0 to 1. So it's defined on a closed interval, but on the open interval from 0 to 1, f is continuous and strictly increasing. Which of the following statements is true? So I need a graph of this to understand this. So I know that f at 0, f at a half, and f at 1 they all have the same value. So how can it be increasing? And so the only way that this could be increasing, because the ends are an open interval, it's increasing like this, where we have holes at the end that allow it to be increasing in the middle, and that these ends are there. So the question is, which one of these is a correct statement? So the function contains a minimum value and a maximum value on the interval. No. That the function attains a minimum value but not a max, and the correct answer is it contains neither a minimum value or a maximum value, because it's strictly increasing. So that means there has to be holes at the end because it's open. So it neither contains a minimum or a maximum value. That was a tricky one. Number 5, can you find the maximum acceleration attained on this interval when the velocity is that? So step number 1 here is to write down the acceleration equation. So when you write down the acceleration equation, that's 3t squared, subtract 6t plus 12. We're going to make it equal to 0, and I want to solve that. So I'm going to divide everything by 3. Now, if I try to solve this, and it's not factorable, so let's say I complete the square. If you complete the square, take the b value, divide by 2, and square it. So that gives me the answer 1. So if I add 1 and subtract 1, you're going to see what's going to happen soon. So if I add 1 and subtract 1, this is what you end up with. T subtract 1 squared. Now, negative 1 plus 4 is 3, but when you subtract it to the other side, can you square a number and it equal to a negative? Like when I try to square root, it's going to be imaginary. So there are no values that make the acceleration 0. So that means that we don't have, and there's nothing also that makes it undefined. So we don't have a relative maximum or minimum. So all that we can look at are the end values. So if I look at the end values, that's at 0 and at 3. That's all I'm going to look at. So which one gives me the greatest number, 0 or 3? So if I plug in 0, I get the answer 4. And if I plug in 3, and I do the work, if you plug in 3, the answer is 21. So the question is the maximum acceleration attained by this particle, and the answer is the maximum acceleration is 21. Number 6, a calculator question. I like calculators. The number of people who have entered a museum on a certain day is modeled by that function where t is measured in hours since the museum opened that day. The number of people who have left the museum since it's open that same day is modeled by g. So, and then you're given the derivatives of both. So let's just make sure we understand what this means. The derivative of f is the rate of people entering. The rate for g is the rate leaving. So when I look at them together, the rate of entering and the rate leaving, I'm looking at what value would be the greatest of that. So first of all, I'd like to know when that rate is exactly even, and then I can test on both sides in terms of that. So first step is I'm going to make it equal to 0, and I'm going to solve that to begin with. All right, here we go. So this is what I want to solve, and I'm going to solve it from 1 to 11. So let me just, I need to see the book so I can type it in right. So f, the rate for f is 380, and it's 1.0 t to the exponent t. Subtract, and we're going to use parentheses, and it's 240 plus 240 sine, and then in the parentheses I want a fraction, and then it's pi, and then it's t minus 4, and then that's over 12. All right, so there's the equation. I want that equal to 0, and then comma t, and then I need a restriction, so I'm going to go control equals, and then go to the vertical line, and then it goes from 1 to 11. All right, so I solved that equation. I want to know when the two rates are exactly the same, and then I can test those to see if that creates a maximum or minimum. So the two answers I get are 7.888, and the other is at 10.97. So if you round it, that's really 11 at the end, and that's our end of our, that's at the end of our restriction. So we have 1, 7.8, and 11. So from 1 to 11, I want to know whether 7.88 creates a maximum, and therefore would be that. So to know whether it creates a maximum or not, I need to understand before and after if it's positive and negative. I probably could have defined it in my calculator too to make it a little bit easier. So if I have 380 parentheses 1.02 to the exponent t, subtract parentheses 240 plus 240 sine, oops, and that's pi t minus 4, and then 12. And then what I'm going to do is I'm going to evaluate that at a number between 1 and 7.8 and see if what the rate is. So I'm going to evaluate it like at t equals 2. And it gives me a positive answer. So that means it's increasing. So I tested, I put a number in, it's increasing, and now I need to put another number between 7.88 and 11. So I'm not going to retype all this in. I'm going to highlight over it, press enter. I'm just going to change the 2 to whatever, 8, some number in between there. And notice that now the rate is negative. So what did we just show? And the question is, at what time is the number of people in the museum a maximum? And so we were already given the derivative. We just need to understand that we need to set it up where you had the rate people going in, subtract the rate of people leaving. When you take that rate as a whole, where does the maximum occur? And the answer was 7.88. That is a really high level question. Number 7. In question number 7, you're given this graph, and it says the graph of the derivative is shown. Which of the following describes the relative extrema of f on the open interval? So if this is the derivative, then when you go from a negative to a positive, that is a minimum. If you go from a positive to a negative, this is a maximum. And the last one here, if you go from a negative to a positive, this is also a negative to a positive, this is also a minimum. And the question is, this then has two relative minimums and a maximum. And that would match with A. A has one maximum and two minimums. Number 8. This one's a toughie, but we're going to do it together. So in number 8, the function h is differentiable for all values of x. And it tells you that h at x equals h times 2 subtract h. And then it says, which of the following statements must be true? So must, by what's based, if I integrate from 0 to 2, will that be greater than 0? So will it be increasing? And we don't know. And so the next issue would be the derivative. So the derivative of h of this, we're going to take the derivative of both sides, and that creates a hook of -1. And then it says h at x equals h at 2x. Well, now we're going to take the derivative at 1. So we're going to plug in 1. Sorry. So if I plug in 1, 2 take away 1 is 1. And it's a negative because of that negative in front. So I'm going to combine like terms. So I'm going to add that to the other side. So now it's 2. But when I add it to the other side, it's now equal to 0. And then when you divide by 2, you get the derivative at 1 must equal 0 if that's true. So 2 times 0 is equal to 0. So the derivative at 1 must equal 0 for this to be true. So it's right there. And the answer is that. Only 2. Number 9. In number 9, the graph of a twice differentiable function f is shown in the figure above. Which of the following is true? And they're looking at the value of the function at 1. So if I said, hey, what is f at 1 equal? You would just say it equals 0. It's right there. If I said, what's the derivative at 1? You're saying, is it increasing or decreasing at 1? And you can see it's increasing. So it must be a positive value. And then lastly, the second derivative at 1, is this concave up or is this concave down? And so you can see that it's concave down, which means the second derivative is negative. Then it says put them in order. And you're putting them in order from smallest to biggest. So this is the smallest, then this is the next, and then this is the largest. So we put them in order. So the second derivative, the function, and then the first derivative. And that would be the order in terms of being negative to positive. So that answer is D. So the second derivative is smallest because it is negative. The next one is smallest because it's 0. And the next one is the largest, or the least smallest. The first derivative is positive because it's increasing. Number 10. In number 10, let's see if I can back out just a little bit here. All right, so there you're given the graph of a function. And in number 10 it says, which of the following statements must be true? Does f have a relative minimum at -3? So we went from a negative to a positive. So yes, I like that. That is a minimum. So I would say that one is true. For the next one, for some reason I can't focus in, so there I have to be a little bit closer. The graph of f has a point of inflection at -2. And that answer is no. So at -2, you don't have a point of inflection. This is a derivative graph. So the point of inflection would be right there where it changes direction. So at the turning point, there's a point of inflection looking off the first derivative. So number 2 is false. And then number 3, the graph of f is concave down from 0 to 4. So if it's concave down from 0 to 4, this would be decreasing. It is decreasing, so that answer is yes. So the first derivative is decreasing. That means concave down for the second derivative. And so the last statement is true then. And then turn the page, so it's 1 and 3. And so the answer is E. All right. I want you to notice that number 11 is the same question. That's a typo. Same question. Number 12. If you look at number 12, the figure above shows the graph of the first derivative from -6 to 8 of the following, which describes the graph. And they're just talking about minimums and maximums. So the first thing I see is it goes from positive to negative. So that's a maximum. The next thing I see is it doesn't cross over here. So that's not a maximum or a minimum because it has to cross over. And then on the right, it goes from negative to positive. So that part is a minimum. So positive to negative, that's a maximum. Negative to positive, if you like, that's a minimum. So it has one maximum and one minimum. So the answer to 12 is A. Oh, and then it says how many points of inflection. So a point of inflection is a turning point. So that is a POI, that is a POI, and that is a POI. So every time the graph turns from increasing to decreasing, every time it turns from increasing to decreasing, that's what happens. All right. So the answer there was A, that it has a relative minimum, it has a relative maximum, and 3 points of inflection. All right, Mr. G Math over and out. I'm going to do another video in a second.